two things. There's two types of probability distributions. Okay, probability distributions. There's discrete, and then there is continuous. And what we're looking at today is the continuous, okay? And that's this right here is this is how so F would be, F is, in this case, F is a probability distribution function. And it can take on any value. Well, sometimes you can have these that can take on any value from negative infinity to infinity. And but these two right here, the second, so this is how it works. The probability that x is between a and b is the integral from a to b of f of x dx. Now, you have to have these two conditions. Those are conditions. So necessary conditions. And as well as this, you know, f of x has got to be greater than or equal to 0 everywhere. It's got to be non-negative. You can't have a negative probabilities. Okay, so this one right here is basically just saying that wait a minute. This is not a condition. Oops. That's necessary. That's a necessary condition. The saying is that the probability that you're between negative infinity and infinity is 1. So you will land something in there, in that interval. Okay. We'll get to this one later. So here's a couple of examples right here. Let f of x be the probability density function. So that's what, it's a probability density function. Oops. Density function. Okay, that would be our f of x, like that one. For the lifetime of a manufacturer's highest quality car tire, where x is measured in miles. Okay, explain the meaning of each integral. So the probability that you're between a and b is the integral from a to b of f of x dx. Okay, so this will represent the probability that will have a lifetime of between 40,000 and 50,000 miles. Okay, because that's what you're integrating across. Okay. So that would be the answer to that one. And then part B, you're going from 35,000 to infinity is your integral. So that's going to be at least 35,000, this one. So 35,000 or more. That's the probability that it's 35,000 or more. Okay, and then this right here, this formula right here, this is the mean. This is the mean for the probability distribution. And then these other two are just examples. This is this right here, this one. This is the normal distribution. And this last one right here, this is the exponential distribution. Or exponential density function. Okay. And for this one, it turns out that the mean is 1 over c for that. Okay, and so this one is this formula for t greater than or equal to 0. And it's 0 if t is less than 0. Okay, that's what the function is. So a lot of these, they're going to have places where it's just 0, typically. Sometimes. This one doesn't. The normal distribution doesn't. Okay, so that's a little bit of an introduction, and hopefully you have a little bit of understanding of probability right here. So let's do some more homework problems. Okay, so number 2. So here, f of x equals k times, so this is going to be a probability density function if x is between 0 and 5 and is 0 elsewhere. Okay. So for what value of k is f a probability density function? For what value of k is f a probability density function? Okay. So again, for part A, it's this condition that is what we're looking for. That needs to be 1. Okay. Integrating from negative infinity to infinity. Now, since it is 0 when x is less than 0 and it's 0 when x is greater than 5, then we can just integrate from 0 to 5, okay? Because outside that interval, it's 0. And when it's in that interval, then it's this. Okay, so we just need to find a value of k that makes that equal to 1. So we integrate that.
Excuse me,
integrating.
why does it equal 1 again?
Because of this condition right here.
Oh, okay.
Because for probability, you can't have anything more than 1. So like, for example, you could say, okay, what's the probability that's going to rain today? And that would be, you can't have more than 100%, right? You can't, or more than 1. Okay, so if you said the probability that it's going to rain today is 60%, then that would be 0.6 for rain, but it would also be 0.4 that it's not going to rain. And that 0.6 and the 0.4 have to add up to 1. Okay, because you wouldn't, it would be ridiculous to say, oh, there's a 60% chance that it will rain today, but there's a 70% chance that it's not going to rain. No, that doesn't make any sense. Okay, 60% chance that it'll rain, 40% that it won't. 0.6 and 0.4 add up to 1. Here it's a little bit different because you're saying what's going to happen. There's going to be some event, and the outcome is going to be some number between negative infinity and infinity. It's going to be some number in there, okay? So that probability that's between negative infinity and infinity is just 1, okay? But as far as like being a specific value, that's kind of hard to pinpoint. So what we have is ranges of values, okay? Okay, so let's go ahead and take the integral. So this is 5x squared over 2 minus x cubed over 3, and that's from 0 to 5. And if I plug in the upper and lower limits, plugging in the 0 gives you nothing, so that's good. So if I plug in a 5, I get 125 over 2, and here I get 125 over 3, and that's going to give me 125k over 6 when I add those together. And that has to be 1, so k has to be 6 over 125, okay? So 6 over 125. Any question about that? Okay, part B. For what value? For that value of k, so this value of k. Okay, so now if you put that value of k in there, then we have a probability density function. What's the probability that x is greater than 1? Okay, and that's going to be again, it's going to be from 1 to infinity. But because it's 0 beyond 5, then we're just going to go from 1 to 5. And we're going to put the value of k in, so that's 6 over 125 times 5x minus x squared. Okay, so okay, so we're going to get 5x squared over 2 minus x cubed over 3 divided from 1 to 5. And when you put the upper limit in, you're just going to get that, which is 125 over 6 when you put the upper limit in. Okay, and when you put the lower limit in, you're going to get 5 halves minus 1/3. And then that's all multiplied by 6 over 125. Oops, I didn't save enough space to put that on the front. Oh wait, maybe I can fix that. Hold on, let me put that on the front. Okay, so we get that, and that turns out to be 0.896. Exactly. So that was like, that gave me like a decimal that kind of just works out. I guess I could put that in a fractional form and it'd probably still work out. Now, one thing to remember is probabilities. Maybe I'll put this on the first page. Okay. Probabilities are always between 0 and 1. It's always between 0 and 1. The probability that it's going to happen. You can't have anything more than 1 and anything less than 0. You can't have more than 100% chance of something happening, or you can't have less than 0% chance of it happening. So that's another condition. Okay, so if you're doing these problems and you ever get an answer that's a probability like this, that's not between 0 and 1, then it's wrong. The answer is just wrong. Okay, now the mean. Finding the mean. Okay, so here's the formula for the mean right here. And so you take the integral. Here, this time it's just going to go over where the function is non-zero. We'll just start off with that from the beginning. But you're going to multiply by x, and then you're going to multiply by the rest of it. Right there. Now, when you integrate, of course, you have to distribute the x first. We can go ahead and integrate this. Nice, the lower limit is 0, so that's really great. Don't get used to that, though. Okay, so that's going to be, okay, so you have 5 to the 4th over 3 minus 5 to the 4th over 4. That's going to be 5 to the 4th over 12. And let's see here. This is 5 to the 3rd, so that's going to wipe out let's wipe out 3 of those. That's just a 5. And then this is going to reduce that to a 2. So in the end, I get 5 halves. For the answer as the mean. And the mean, so like if you were to repeat this experiment a whole bunch of times, then you're going to get values between 0 and 5 every time. But as you do it more and more and more, then the mean is, by the law of large numbers, the mean is going to get closer and closer to 5/2 or 2.5, which is like the midpoint of this interval, but that's not necessarily always going to be the case. Okay, any questions at this point before I go on and do more stuff? Okay, great. Let's go to number 3. Okay, so this right here is the exponential distribution. And it says an online retailer has determined that the average time for credit card transactions to be electronically approved is 1.7 seconds. Use an exponential density function to find the probability that a customer waits less than a second for a credit card approval. Okay. So I said on the first page that C is 1 over the mean. Okay, and the mean is average, so average is mean. And so this is right here. But let me just kind of show you why that's the case. Okay. So the mean is integral from, okay, this is for t greater than 0. So it's 0 to infinity of c e to the negative ct times t, I'm sorry. Okay, so for the mean, you put in a t there. Okay, so you want to integrate this. Let's see, what's the integral going to be? T e to the negative ct. So if you, okay, I'll put a negative. So if you differentiate this, you'll have the derivative of this piece, which will be this times negative c. Okay, the negative will take that out, and there's the c. And then you'll have the t times t. But then you'll also have, okay, so you'll have ct e to the negative ct, which is good. But you'll also, by the product rule, you're also going to take the derivative of this part, which is 1, or negative 1, e to the negative ct. Okay. But we can get rid of that by that. Okay, so when you take the derivative of this, you get a negative c coming down that cancels that, and it cancels the negative, so you have e to the negative ct. And then those are going to cancel. Okay, so you'll just get this if you take the derivative. So that's the derivative, right? That's the antiderivative right here. And you evaluate that from 0 to infinity. Now, as you go to infinity, this is going to go to 0, and this is going to go to 0 as t goes to infinity. Both those are going to go to 0. Okay, so you'll have 0 minus, and then when you put 0 in, that's going to be 0. And this one is going to be a negative 1 over c. Okay, so you get 1 over c. Okay, so that's where you get that the mean. Okay, so that's telling you the mean is 1 over c, which tells you that c is 1 over the mean. Okay, so for this problem, for part A, c will be 1 over 1.7. Okay, now less than a second, that means you're going to integrate from 0 to 1. That's less than a second. 0 to 1. And c is 1 over 1.7, so 1 over 1.7 e to the negative 1 over 1.7 t dt. Okay, you integrate that. and we have negative e to the negative 1 over 1.7t. Because you take your derivative, you'll have a negative 1 over 1.7 come down. The negative will get canceled, and 1 over 1.7 is right there. Okay, and that goes from 0 to 1. So when you put a 1 in, you have negative e to the negative 1 over 1.7. So that's putting a 1 right there. And then you subtract, put a 0. When you put a 0 in here, that's e to the 0, which is 1. Okay, so you get that. And it says, the problem, I don't have it written here, but it says round your answer to 3 decimal places. So I plugged it in the calculator and got I plugged this into the calculator and got 0.445. Okay, for the first answer. Okay, then part B, find the probability that the customer waits more than 3 seconds. That would be from 3 to infinity. Again, when you integrate, you're going to get the same thing. But you're going 3 to infinity. Okay, so more than 3 seconds means 3 to infinity. Okay, now as you go to infinity, this is going to go to 0 because you're e to the negative number. So that's 1 over e to a positive number that's getting larger and larger and larger. So that's going to go to 0. And you subtract and put a 3 in, you get e to the negative 3 over 1.7, which, again, using a calculator, I get approximately 0.171. And then finally, the third part, what's the minimum approval time for the slowest 5% of transactions? So the minimum approval for the slowest 5% of transactions. Okay, so slowest means larger times. Means more time. Okay. So if you let t be that minimum, the t be the minimum, then what it's saying is if you integrate from t to infinity, so the slower means larger times from t to infinity of you integrate our probability density function from t to infinity, then you'll get 0.05 if t is the cutoff point. Okay, so then t to infinity is going to be 0.5. Okay. So basically, this is saying the probability that t is between t and infinity equals 0.05. Those are the slowest 5% of times. Okay, so if you evaluate this, you get this again. Evaluate it from t to infinity. But when you plug the upper limit in, you get 0. When you plug as you go to infinity, this goes to 0. And then you subtract into the lower limit, you're going to get e to the negative 1 over 1.7 capital T. Like that. Take natural logarithm on both sides. Okay, the natural logarithm of this is just what's up here, and the natural logarithm of this is just log of 0.05. Okay, and then t is negative 1.7 times the natural log of 0.05. Okay. Now, some people might be thinking, and rightly so, but Brother Hurst, we can't have a negative numbers as you can't have a time being a negative number. And there's a negative right there. Oh dear. Okay, well, it turns out that when you're taking the log of anything between 0 and 1, you also get a negative number. So those will cancel each other off. You put that in the calculator, and you get approximately 5.092745. So you round that off to 3 decimal places, 5.093. And that would be the answer to that one. Okay. Do you have any comments or questions about any of these exercises thus far?
Excuse me. So start from the beginning, like mu equals to the integral CTE. Like why there's a t there?
Yeah, why did I put the t there? Here?
Yes.
Okay, that's a great question. I was going to answer that, but I forgot to. It's because we're calculating the mean. Okay, so the mean here, you put t there. You put the variable in there, extra variable.
Oh, I see. Thank you.
Let me kind of explain that in a different way, though. Okay, so let's say that we have let's see, how can I put this? Let me just kind of introduce you to I think I'm trying to see how this goes. Well, let's say that I have 3 students take exams, okay? And so I have one student that gets a 90 on the exam, the student A, and student B gets an 80, and then student C gets a 60. Okay, we'll just say that, for example. Now, okay, if I select, let's do this. Let's say that we have. Let me change things up a little bit. Okay, let's say that we have 2 students that get 90s and 2 students that get 80s, and only 1 student that gets a 60. Okay. So if I select an exam at random, then the probability that it's a 90 will be 2 out of 5, right? And the probability that it's an 80 will be 2 out of 5, and the probability that it's a 60 will be 1 out of 5. Okay? Does that make sense? So there's 5 students. So 5 students, and these are, 2 of them got 90, 2 got 80, and 1 got 60. Okay, if I select an exam at random, the probability it's a 90 is 2/5, the probability at 80 is 2/5, and probability at 60 is 1/5. Okay, now the question is, what is the average score? Okay, what's the average score? So if I select exams at random and then I put it back and I select another one at random and I select another one at random, and then I take the average of all those and I just keep going and going and going and going and going, what's the average going to be? Well, the average, because I have, for the average, I'm going to multiply. I can do it this way. I can take 90 and multiply that by the 2/5, and I can take 80 and multiply that by 2/5, and I can take 60 and multiply that by 1/5, and that will give me the average. Okay, if I do that. Okay, does that make sense that I do that? If I do that, I'll get the average. Okay, another way. Okay, so let me show you another way. Another way that you could do it is you have 2 90s, right? If I just add all the scores up and divide by how many there are, that's going to be the average too, right? But this is pretty much the same thing, because these 2 divided by 5 is this, these 2 divided by 5 is this, and this divided by 5 is this. Okay, so that's the average. Okay, now what's happening here? Let me summarize what's going on here. Okay, first of all, if I add these 3 together, I get 1. Okay, if I add those 3 together, I get 1. That corresponds to the first condition, this one right here, this condition right here. That you add them all up, you get 1. You add up all the probabilities, you get 1. Okay. Now, this one right here, these scores right here. Okay, so instead of adding that and that and that, I'm multiplying. These correspond to multiplying by x. Okay, so that corresponds to, so the equivalent thing here was to find the mean, you multiply the scores by x, by the value of the score. You multiply the probability by the value. Okay. Okay. So that's kind of where that comes from. So we just have one more to go. Oh no, we don't have much time. I promised you guys would get out early. Okay. Well, I still have 10 minutes to get done. Okay, so this one is this right here is, this distribution here is the normal distribution with where the mean is mu, this u thing, mu, and the standard deviation is sigma. Okay, so sigma. Okay, so let me give you instructions on how to do this. You write a sigma. If you're going to write a sigma, okay, you don't write it like a 6. So 6, you write like that. No, you don't write it that way, because you start here and go down for a 6, right? So for a sigma, you start here and go the other way. Okay, so do that way. Okay, so that's a sigma. That's what these are. Okay, so boxes are labeled as containing 600 grams of cereal. The machine filling the boxes produces weights that are normally distributed with standard deviation 13 grams. Okay, so if the target weight is 600, what is the probability that the machine produces a box with less than 580 grams of cereal? Okay, so this is telling you that mu should be 600, and then you also know that the standard deviation is 13. Okay, so the normal distribution that we're talking about is this one. It's over 13 times the square root of 2 pi. And then e, let me write this e bigger. So e raised to negative x minus 600 squared over 2 times 13 squared. Yeah, like that. Okay, so that's the distribution that we're talking about. And what's the probability that the machine produces a box with less than 580 grams of cereal? Okay, so this means negative infinity to 580. Okay, so that's what that is. So that probability is equal to the integral from negative infinity to 580 of this function here. Okay, now this function right here can't be integrated. Well, it sort of can, but I guess you could say yes and no. It's kind of yes and no. It's kind of a mixed answer. But basically, the bottom line is it's not any function. When you integrate this, you're not going to get any function that you've ever seen before, unless you've done this before. Okay. So let me show you how you would do this. So we'll go to let's go to our good friend GeoGebra and say, GeoGebra, help us out here. Right, so what the, oops, oh, typed it in wrong. Okay, so I'm going to go to the CAS calculator. Make this nice and big. And because I don't need the graphing part, I just need the integral part. So integral, okay, and put the function in. That's going to be 1 over 13 times the square root of 2 pi. And then that's going to be multiplied by the exponential function. So exp of negative x minus 600 squared divided by 2 times 13 squared. And you come all the way out there, and that's going to go from, what did I say, negative infinity to 580. Okay, so when you integrate it, you get this ERF, or I think it's the error function, but really what we need is just the approximation. Which is 0.06196, which you just need 3 decimal places, so 0.062, okay? So go ahead and put that in. Oh, what did I do? Okay, so GeoGebra 0.062. Okay, gave me 0.062. Okay, part B. Suppose the law states that no more than 10% of a manufacturer's cereal boxes can contain less than the stated weight of 600. Now, what target weight should the manufacturer set its filling machine? Okay, so here they were setting it as 13 grams. And so here it's like, what are you going to set the machine at so that no more than 10%? So you're basically looking at this number here, 10%. Okay, so now this is so then now the function is this right here. The standard deviation is still 13, like that. Okay, so now the function is this, but the mu is kind of left up in the air, and you want to know, you don't want to have any more. No more than 10% is less than 600 grams. Okay, so from negative infinity to 600, you want that integral to be less than 10%. Okay, and so you want to know, and it says find it to the nearest gram. Okay, so you want this integral right here to be less than 0.1. Okay, so I'm going to go back to GeoGebra and try to like put that in there. Okay, so let's see, what did I say? Let me just copy that whole thing. What the? Okay, copying didn't work. Okay, I'm just gonna write over it. Okay, because all this stuff is there that I want, except I want to put something. I want to integrate from negative infinity to 600. Now, if I do that, I'm going to get 0.5, by the way. But I want to adjust this number here, this 600, until I get something, until it's less than 0.1, less than 1%. So if I go higher, that's going to be better. So if I go like 604, for example, then when I do that, that's going to give me 0.397. So I still want to go a little bit higher. So maybe 610. We'll try 610. Okay, that's still 22%. So just keep going higher. Let's see, if I go 617, let's try that. Okay, that's less than 10%. Maybe that's the answer. Okay, we'll just try 616. That's more than 10%. So the answer is 617. Okay. So because 616 is more than 10%, and 617 is less than 10%. Okay, that's 9.5%. Okay, so it's 617.